Yes, class. Am I audible to all of you? Ali, Aisha, Ubaidullah, Safrina, Anisa. Is it audible, class? Okay.
Yes.
Could you just tell me where did we exactly stop in the last class? Which part?
Faraday's law.
Faraday's law. So, did you write this? All these points?
No.
Okay, I think till here you all have written. From here it was left, no?
Yes, ma'am.
Okay. See, before you start writing this, let me just quickly revise what we've already discussed. The first thing that we saw was the magnetic flux. What was magnetic flux? Number of magnetic field lines crossing a surface perpendicularly, or which we say normally, right? And the formula of magnetic flux was similar to electric flux, that is B A cos theta. B dot A, B A cos theta. Now, see, then Faraday did certain experiments, and where it was proved that whenever magnet was coming near a coil, the current was being induced in the coil because we could see it through the galvanometer. Now look, Faraday gave laws of EMI. First, he said whenever there is a change in the flux. Change in the flux means whenever magnetic field increases, decreases, or magnetic flux increases, decreases. You're not concerned only with increment. Anything, any change is there. Then a current is induced in the circuit and an EMF is also induced in the circuit. So till here only we completed, and this part was left, right? Look, class. Basically, Faraday said that the EMF which is induced is directly proportional to rate of change of flux. Now, rate of change of flux means d phi over dt is the rate of change of flux. Flux changing with respect to time. So rate of change of flux is d phi over dt. It says that whatever is this induced EMF, this is directly proportional to rate of change of flux. So we can say that induced EMF is equal to minus d phi over dt. This becomes the formula of it, minus d phi over dt. Now, why do we have this minus sign? This I'll discuss in the Lenz law. You'll not be able to understand. There's a law, Lenz law. That time when we'll discuss, then you'll be able to catch up this. But for this part, when we write this Lenz law, right now you can just put a negative sign. In detail, we'll do later. There's one law, that is Lenz law. I'll discuss that later. So E is equal to minus d phi over dt. So see, you can directly write this as minus delta phi over delta t also. Basically, this is the change in flux. So you write final flux minus initial flux, and this is the change in time, final time minus initial time. Now it depends on what quantity is given. If you have to calculate at a time instant, then use this. If a duration is there, use this. Now, see, if resistance is given, let's say R is the resistance, and what will be the induced current? EMF is equal to IR using the Ohm's law class. If this is Ohm's law, from here, if I put the value of this, d phi over dt is equal to I into R. So what will be the formula of the charge from here? Minus 1 by R. This will be minus 1 by R d phi over dt. Here a minus sign would also come for electric field. So this is also a formula of current which you can use, and this question has come in the exam. One more formula is possible, class, if I take electric charge. See, I is equal to dq over dt. Now in this, let me place in this formula only, I am putting the value here. This value, I am putting it here. So what will be it? dq over dt is equal to minus 1 by r d phi over dt. Now see, from here dt gets cancelled. So what's the value of this charge? dq or q, you say this is minus change in flux by the resistance. Yes, when I write d phi, it's not necessarily d phi only. This means whatever is the change in the charge can be written as change in flux divided by the resistance also. Similarly, here for current also you can say 1 by r minus delta phi by delta t as well, because see, that depends upon what's given to you. So these are various formula that you can use. What all things are there? See, this is the formula for the induced EMF. This is the formula for the induced EMF according to Faraday's law. Faraday's laws of EMI are what? First law is that whenever there is a flux changing in your circuit, there is an induced EMF. First point is that magnetic field will change, magnetic flux will change, and you will have induced EMF. Second point is that this EMF will be directly proportional to rate of change of flux. Higher the change, higher the EMF, lesser the change, lesser the EMF. Then for the different formula, you can use this where I is equal to the electric current and Q is for the charge. This CQ. This is for the electric charge. Yes, class. The formula part is clear to all? This much? Got it? Others also? Aisha, Ali. Alright, Ubaidullah? Clear?
Yes, ma'am.
Alright. So please just write down whatever you have not written from the last class, then we'll continue.
Ma'am, in last class, I wrote first law. Ma'am. Ma'am, that is E or epsilon naught.
This is EMF.
Yes, ma'am. Can we write E?
Yes, this is E. You can just write this as E. You can write this V, which is equal to E only. It's the same thing. Okay, it's E only. Just write it as E. Done, class?
Ma'am, this D and delta is same thing only.
Yes, D you use for differentiation when you have a quantity infinitesimally small. Means when something is depending on a very time instant, when you have to calculate at a particular time instant. Let's say t is equal to 2 seconds or something. For instant, then only use this. So this you can use for a duration when you have initial time, when you have a final time. Okay.
Yes, ma'am. One is differentiation and one is difference.
Yeah, exactly. This is differentiation. This one is just difference, subtraction.
Yes, ma'am.
Obedullah, you have also written or are you still writing?
Last. Done.
See, this question says that a 10 ohm resistant coil has had 1000 turns, and at a time 5.5 into 10 to the power minus 4 Weber of flux passes through it. Means resistance is given as 10 ohm, number of turns, this is 1000. What's the initial flux? Initial flux is given as 5.5 into 10 to the power minus 4 Weber. This is the initial flux. It then says if flux falls to, means now the new flux, final flux, it is falling up to 0.5 into 10 to the power minus 4 Webers, and the time for this process is 0.1 seconds. It says you have to find out the EMF and the charge. EMF in volt and charge in coulomb is basically in the SI unit. See, EMF is equal to minus delta phi over delta t, because see, initial and final is there. So we will take out the difference. Final flux minus the initial flux divided by the change in time. So minus final flux is 0.5 into 10 to the power minus 4 minus initial flux is 5.5 into 10 to the power minus 4. This is the change in the flux by time is 0.1 seconds. See, this is just for one turn, okay? 1000 turns are given. This will be 0.5 minus 5 with 5 only. So minus 5 into 10 to the power minus 4 divided by 10 to the power minus 1. Look, this will be 5. This one goes up. So 5 into 10 to the power minus 3 volt. But this is for one turn. So for n number of turns, it will be minus n delta phi over delta t. That is 1000 10 to the power 3 into this, what we've already calculated, 10 to the power minus 3. That gives 5 volt as our answer. Okay. 5 into 10 to the power minus 3 for 1 turn. So for 1000 turns, it will be this whole thing multiplied to 1000. Even you can use it from the starting, just make the formula directly. You can use this also. E is equal to minus n d phi over dt or delta phi over dt. You can use this formula also. This is also absolutely right. And second part said charge. Okay. See, charges formula we've already seen. It's the change in the flux divided by resistance. See here, change in the flux by the resistance. So flux changes minus 5 into 10 to the power minus 4 divided by resistance is 10. This is 10. That becomes 5 into 10 to the power. This goes up. This is minus 1. So minus 5 coulomb. This is the charge. This directly formula we will use. So this is the first part for the voltage. This is the second part for the charge. Got it?
Ma'am,
Yeah. Yeah. Say
for charge we don't have to multiply.
the number of turns. No.
Yes.
No. For charge, you don't have to multiply.
How we got 0.1
Where?
delta t?
That's given in the question. This. Okay. Here.
Yes, ma'am.
Please write one more question we will see. Done?
Last. Done.
All right. There is one more question. This question, I think, is from your NCRT. A similar question is there in your NCRT, where the values are given. Like instead of the area, the radius of the coil is given, and the magnetic field horizontal component is given. So that I'll give you as an assignment, so that we can discuss it in the next class. See, basically, what does it say? It says that a coil is there of cross-sectional area A, okay, in uniform magnetic field B with its plane perpendicular to the field. In this position, normal to the coil makes an angle of 0 degree with the field. This is the coil. The normal means perpendicular to this coil makes an angle 0 degree with the field. Like field is also this, and perpendicular will also be this. Okay. This says that the coil rotates at a uniform rate at one rotation in time t. See, how will the coil be rotating? This is it, then this, then this, then this, then this, back to its point. So 0 to 90 degree, 90 to 180 degree, 180 to 270 degree, 270 degree back to 0 degree. Like if I show you it, it would be like this: 0 to 90, 90 to 180, 180 to 270, and 270 back to 0 at 360. Now it says initial angle is 0 degree. Means this is the plane of the coil, and this is its area vector, and the magnetic field is also like this. Then it says 0 to 90 degree. 0 to 90 degree means it has rotated to 90 degree. So see, area vector will be like this, and the magnetic field will still be like this. Like this. Okay. So this way all the values are getting changed, but you don't need to focus on this much. Your answer will come out through the calculations very easily, class. So how will you calculate this? 0 to 90 degree. See, first let us identify the time. Just tell me one thing, class. Total time this is in the one complete revolution, one complete rotation. It's time t. This says no, one rotation is time t. Okay. So when we say one rotation is time t, it means for the entire 0 degree to back 360 degrees time t. Okay. We can say total time is equal to t. Now tell me from 0 to 90 degree, what do you think will be the time taken? If total time is t, what should we write?
T/4.
Yes. Very good, Ubaidullah. See, this is, if you see here, this is just 1/4 of the total time. So time from 0 degree to 90 degree will be t by 4. So time is sorted. Now let's talk about number of turns are given. Number of turns are in there. Now initially, let's calculate the initial flux. Initial flux means the 0 degree. So we'll have B dot A as our formula. So this will be BA cos 0 degree because initial angle is 0 degree. Now cos 0 is 1. So this becomes BA. Okay. Now, when we talk about the final flux, what's the final angle? 90 degree. It goes from 0 degree to 90 degree. So this becomes 90 degree. So when you take B dot A, this will be BA cos 90 degree. Straight away, you know this is 0. Now let's implement this. E is equal to minus delta phi over delta t. This will be minus final flux, initial flux divided by change in time. Final is 0 minus initial is BA divided by time is T by 4. So minus minus will become plus BA by T by 4. 4 goes up, this becomes 4BA divided by T. Tell me, is this clear to all? Second part says 90 degree to 180 degree. What will be the time here in 90 degree to 180 degree class?
Same, I think.
T by 3. Safrina, did you just answer this right now? The last one which you have written? For this one? This is for 90 to 180, Safrina, your answer?
Yes, sir.
Okay. What about others? 90 to 180. See class, why are you getting confused? Treat it like a mathematics question, fraction. What you do, 90 degree to 180 degree is also this part. So why are you getting confused? This will also be T by 4 only. This will also be T by 4. It's 1/4. So if it is 0 degree to 180 degree, then Safrina, your answer was right. T by 2. If it is 0 to 270 degree, then 3T by 4. So this way you have to just get the values, okay, for the time. When time is done, now see again initial flux we'll calculate, that is BA cos 90 degree. So our first value will be 0. What will be the final flux? BA cos 180 degree. That is minus of BA because cos 180 is minus 1. Now EMF will be again minus delta phi divided by delta t. It will be minus final flux minus initial flux divided by the time. So minus, finally it is minus BA, minus initially it was 0. See class, this is a coincidence that your answer is coming same in both the parts. Answers can be different. This is not a standardized value. मतलब इसको याद मत कर लेना 4BA by T as a final answer. Answers can differ depending upon the values or magnitudes that are given to you. Though in this question, this is coming same thing in both of them, that is 4BA by T, but this is again I'm saying this is not a standardized answer. Anyways, the application is clear to you because NCERT has a very similar question to this. I'll share that in the assignment as well. Yes, Ali, Anisa, Aisha, Ubaidullah, Safrina, got it?
Ma'am, how are we getting T by 4 for delta T?
For
Delta T.
T by 4 is the time, no? Time duration. So time duration because 1/4 of the total time is taken. For 360 degree T is there. So from 1/4, you only answered that, Ubaidullah. T by 4 you get it? Why T by 4?
Means it is a difference. Delta T means TF
Delta T
minus
means
T.
time duration. Okay. Delta T basically means the time duration.
Yes, ma'am.
Okay. All right, class. So I just have one more class right now. So we'll just have this class for 1 hour today, and this half an hour will be compensated in the next class. Okay. So this, by the way, completes with Faraday's laws of EMI topic and magnetic flux. Now in the next class, I'll complete Lenz's law and motional EMF. Okay. Then only one topic, induction, will be left. So two classes, and the chapter will probably be over. Okay. All right then. Okay, class, then you can leave. Thank you.
Thank you, ma'am. Thank you, ma'am.
Ma'am, I am not able to see the screen downward part. Done, ma'am. Thank you.
Done?